Microplastics. Every ocean, every waterway, even the food we eat, contains an increasing amount of these invisible particles. But what happens when tiny creatures at the bottom of the food chain ingest them? Today, we're going to feed fluorescent microplastics to brine shrimp and watch them glow under the microscope. I recently discovered this kit from Algae Research Supply, which provides you with the tools you need to observe the bioaccumulation of microplastics in brine shrimp. Algae Research Supply are an American-based company who sell various algae species, culturing equipment, and educational kits, just like the one we'll be looking at today. Now, this set would usually also come with live brine shrimp, but I was doubtful that they'd survive the long journey across the Pacific Ocean to get to me, so I asked them just to send me the fluorescent food and culturing equipment instead. Luckily, I already have more of these guys than I know what to do with, so we're covered in that department. The intended purpose of this kit is to feed microplastics to adult brine shrimp, and then watch the food in their digestive tract glow under UV light. And while we definitely will be doing this in today's video, I'm also curious to see what happens if we actually raise the brine shrimp from infancy to adulthood in an environment that's already filled with these microplastics from day one, kinda like how we've all grown up with this glorious stuff our whole lives. So I'm planning to set up a few tanks using fresh aquadragon kits so we can use them as our test subjects. Alright, that's enough delay, let's check this kit out. We'll start off first with the info sheet, and there's a lot to look at here. Up the top in yellow is the kit's name, Brainy Briny Fake Fluorescent Food. So when I first read this, I was a bit confused by what they meant with the word fake here, but I'll explain what I think they mean when we come around to looking at the food. On the left is a picture of the kit's contents, an introduction explaining how this kit will help us to understand the effects of plastic pollution on marine ecosystems, and a list of the included materials. In the middle is some setup instructions. It basically just tells you how to give the adult brine shrimp the microplastics and then make them glow under UV light. We of course won't be using this kit in its intended way, so I won't be following these steps all that closely. On the right we have some anatomy diagrams for male and female brine shrimp, and an explanation of why they're such perfect animals for this experiment. Aquadragons are passive filter feeders, meaning that unlike most animals, they don't actively seek out food to eat, but rather they just consume anything that's small enough to fit into their mouths, and they do this by constantly eating, which is also why they're always swimming about. Usually this approach to feeding is fairly innocuous. They'd be feeding on things like algae, bacteria, decaying organic material, that kind of thing. But in our modern world, this has also come to include inorganic material, like the microplastics which have permeated every ecosystem on our planet. Below the Artemia diagrams is an explanation of the food which is included with this kit. I think they call it fake fluorescent food, not because it has fake fluorescence, but rather because it's not actually food. It's very finely ground acrylic powder. Since these microplastics aren't digestible and won't offer our aquadragons any sustenance, I can understand why they're saying it's fake food. It's just that the wording is a little unusual. Over on the back, and we're given some information about microplastic bioaccumulation. This diagram is actually great for explaining how microplastics find their way into our bodies, but we'll look at this topic a little later in this video. And down the bottom we're given some resources for learning more about this ever-growing problem. Okay, so now for the contents. There's a magnifying glass, which we won't need because I have a microscope, a small pipette for moving our brine shrimp around, 3 little plastic dishes. I'm not really sure exactly what these are for. I'm guessing you're supposed to put the Artemia in there for easier observation or something. We have 2 LED black lights, which we'll be using to make our microplastics glow, and also 2 50ml tissue culture flasks. These are designed for housing your adult brine shrimp. I know they're small, but those of you who've been following this channel for a few years will be well aware that brine shrimp can survive in surprisingly small containers if they're given proper care. Now, tissue culture flasks like these ones are usually used in science labs for growing and maintaining cell cultures in a controlled environment. While the lids look sealed, they actually have a little filter in them that allows air to flow in and out, while still maintaining an element of sterility. Brine shrimp do benefit from having an abundance of oxygen in their water though, so I'm going to remove the little filters from inside the lids. For what we're doing, having a perfectly sterile and pure culture isn't particularly important. And since I am planning to grow aquadragons as the test subjects for this video, I will be needing a larger container, so I went ahead and bought some more culture flasks, but these ones are about 5 times larger at 225 mils or 7.6 ounces. Even though they're still quite small, I suspect that these things will make great tanks for brine shrimp, as the walls are perfectly flat and the plastic is crystal clear, which should make for an ideal viewing experience. And lastly, we have our fluorescent acrylic microplastic food. Its yellow colour is really vibrant, but it doesn't look like too much to the naked eye, so here's a quick look at it under the microscope for those of you that are curious. This stuff is surprisingly finely ground, so even though brine shrimp are really small, even our smallest aquadragons shouldn't have any trouble eating it. Now, before we get underway with this experiment, I want to quickly show you some of the digital worksheets that Algae Research Supply have included with this kit. It was really designed to be used in a classroom setting as an educational tool for biology students. They have some great slideshow presentations that introduce you to what Artemia are, how this kit is designed to work, and demonstrate the scientific process of observing the bioaccumulation of microplastics in these small animals. One section of this lesson plan really caught my eye. It mentions how these microplastics might actually affect the animals, stating that ingestion of microplastics can cause physical damage to their digestive system, leading to reduced feeding efficiency and nutrient absorption. It'll be interesting to see if these effects are something that we observe in our test subjects. Alright, let's now move on to the experiment. We'll be setting up 3 tanks today, each with a different purpose. The first is just a control group. They won't be given any of the fluorescent microplastics. Instead, their job is just to establish what happens under normal conditions, giving us a baseline to compare to the experimental groups. We'll call these guys the silent generation, named after those born between 1928 and 1945, a lucky group who lived in a world that existed before the widespread and ubiquitous use of plastics. This second tank will also spend their infancy and adolescence in a plastic-free environment, but once they reach adulthood, we'll introduce the microplastics into their tank to see what happens. This tank is how Algae Research Supply intended the experiment to be performed. These brine shrimp will be like our baby boomers, those born between the years of 1946 and 1964. Boomers experienced childhood and adolescence before the common use of plastics, but by the time they reached adulthood, they were almost as commonplace as what we see today. And lastly, this third tank will be home to our Gen Xers, Millennials, Gen Z, etc. They'll receive their first dose of microplastics on the day of their birth, and will continue adding it into their tank periodically over the next few weeks as they undertake their journey to adulthood. This group represents those of us born after 1965. We were welcomed into a world with microplastics already waiting for us in our mother's breast milk. Yep, that's a real thing. So, at the end of this video, we can compare and contrast the 3 tanks to see what we can observe, and if there are any differences between them. Alright, now I just need to find these guys their new home. Brine shrimp do best in a warm area without too much direct sunlight, and this windowsill only receives a bit of early morning sun, so it's the perfect spot. I'll add a grow light as well to help kickstart some algae growth, which should help to get the nitrogen cycle up and running. It'll only take 1 or 2 days for our aquadragons to begin hatching, so I'll give you guys an update once I spot some movement in the tanks, so we can get our first look at these little guys, and start giving the microplastics to the Gen Xers. Hey guys, it's day 2 today. And as is expected with aquadragon egg packets, we've had a massive hatch rate. I can see a whole bunch of little babies jumping around in all 3 tanks, which means that everything's off to a really promising start. Now, when Artemia first hatch, their mouths and digestive tract aren't actually finished forming yet, and they're incapable of eating food. Instead, they're sustained by an orange yolk-like substance which is already in their digestive tract at birth. This yolk will give them the energy they need for the first few days of life, where they go through some dramatic physical changes as they begin their fast development to adulthood. So, even though they can't eat it yet, we'll be giving our 3rd tank here the first dose of microplastics today. I'm only going to add in a tiny bit, as I'm planning to continue adding in more a few times every week. It looks like this stuff is mostly floating for now, but I assume it might sink over time. We'll just have to wait and see. So, while brine shrimp are filter feeders, they are also known to rub their bodies against tank gunk and debris to search for edible material. In a few days when they're large enough, they'll be able to begin eating these microplastic particles, at which point we should be able to see it light up in their gut. I'll update you again in a week or so from now, so we can see how our fluorescent aquadragons are getting on. While we wait for our shrimp to start growing, I want to remind you guys that if you're interested in supporting the channel, we have a great community you can join over on Patreon. We do monthly giveaways where you can win sea monkey and aquadragon products. You'll get early access to these videos as well as some exclusive ones, and you'll be able to join the picocosmos Discord server where you can chat with me and others in the community. Next month's giveaway will be for the Aquadragon's colour changing aquarium kit, so head on over now and join for free, or enter a paid tier to get some extra perks. Link is in the video description. Morning guys. So the Aquadragons are 10 days old today, and it looks like the colonies in all 3 of the culture flasks are doing pretty well, which is kinda surprising. There's been a bit of a population reduction in each tank, but losing a bunch of babies is fairly standard when starting out a new brine shrimp tank. The ones that have survived the purge are now in their teenage stage, a phase of development where secondary sexual characteristics begin to become apparent, letting us tell the difference between males and females. Regarding our experiment, I've been adding a small amount of the fluorescent microplastics into the tank on the right every day, and surprisingly, it doesn't seem to have had any negative impact on the shrimp in there, at least not in any way that I can see with my eye. It looks like most of the fluorescent microplastics are still just floating on the top of the water anyway, so perhaps the Aquadragons aren't actually ingesting much of it. I would still like to have a closer look at them under the microscope though, so we can see if anything can be observed in their tissue. Now, at first glance here, everything was looking pretty normal. Healthy brine shrimp with some green microalgae in their gut. No obvious sign of the acrylic powder anywhere in their body. So I decided to shine a black light onto it to see if that would reveal anything. And like a Christmas tree, this thing lit up. I thought I might see something, but I definitely wasn't expecting this. The microplastics can be seen right throughout their digestive tract, though what I found most interesting is that you can clearly see more of it accumulating towards the distal part of the gut, with the rectum and colon showing the highest level of density. Basically, their body can't metabolize the microplastics, so rather than being absorbed, they carry on down the digestive tract where they ultimately get pooped out at the other end. Now most of what makes up the Aquadragon's body is their transparent white exoskeleton, which is made of chitin, a structural carbohydrate, and also proteins. It seems that so far, these tissues have been largely unaffected by the microplastics, as the black light wasn't really lighting up these parts of their body. That's not to say these tissues don't have any microplastics in them, it's just that if they do, the concentration is imperceivable. While everything looks fine for now, I suspect the impact of these microplastics should become more pronounced over time, so we'll take another look at the next update in a few weeks. Hey guys, how's it going? We're at day 39 today, which means that our Aquadragons have reached full maturity. We now have a few mating pairs in all 3 tanks, several pregnant females, and the first new babies being born. This is all to say that by the visual metrics I usually look for to determine a tank's health, all 3 of these Aquadragon colonies are doing really well. I initially bought these culture flasks because I thought they'd work well for the experimental angle of this video, and even though they're quite small in volume, they're actually surprisingly nice to use as brine shrimp tanks because of how easy it is to watch the Aquadragons swimming around inside. The only part of the design which isn't really ideal is the small size of the lid opening at the top. This wasn't really an issue when I first set things up a few weeks back, but now that there's a lot of algae beginning to grow on the walls of the tank, it makes cleaning a bit difficult near the edges and up the top in the corners. Anyway, we'll move on to our microplastics experiment now, where we can take a much closer look at our Aquadragons. Of course, the control group on the left representing the silent generation are all looking very healthy. A quick look under the microscope shows us what we typically see with healthy brine shrimp. A clear looking exoskeleton with legs that quickly beat in a wave-like motion. Their gut is a greeny olive colour, the result of a mixture of cyanobacteria and brown diatoms that they've been feeding on. Using a black light here doesn't show anything particularly interesting, because these guys haven't been fed any of the fluorescent microplastics. Next up is the Gen X tank. These are the guys we've been feeding microplastics to the whole time. Now at first glance, I didn't think anything was really off with this tank. It has pretty much the same amount of adults as the others, and other than the plastic still floating at the surface, things look pretty normal in here. It wasn't until I was looking back at some of the macro footage that something unexpected caught my eye. A few of the Aquadragons had what looked like little black spots on their exoskeleton, almost like there was something sticking to them. I decided to investigate a little further. Now, earlier I read you a quote from one of the algae research supply worksheets titled "The Impact of Microplastics on Brine Shrimp and Ecosystem Health." And in here it mentioned that the ingestion of microplastics could potentially cause physical damage to their digestive systems, leading to reduced feeding efficiency and nutrient absorption. And I think this hints at the answer as to what we might be seeing here. I decided to put my afflicted Aquadragons under the microscope to get a closer look. And what I saw was quite surprising. Firstly, I had a look at a female specimen who I thought might have a black spot. Most of her body looked fine. Her legs were moving normally, and she was beginning to develop eggs. She definitely had a fairly large black spot on one of her thoracopods though. Not that it seemed to be hindering her in any obvious way, but it definitely doesn't look right. This next one is a juvenile female, and her condition appears a lot worse, with several black spots on the thoracopods. A quick look with the black light shows that her gut is full of microplastics too, so it seems that this accumulation might be having quite a big impact on her digestion. The last one I looked at here was one of the larger adult males, and he didn't look much better, with a whole lot of black spots affecting different parts of his exoskeleton. I counted at least 5 which were pretty large, and this one on his clasping antenna was so bad that it actually caused a notch to be cut out of it. And while it doesn't look that significant, the shape of these antennae is actually really important, and this deformity could potentially have a negative impact on his ability to latch onto and mate with a female. Interestingly, all of these black spots were either on their legs or, in the male's case, his clasping antennae. For whatever reason, the abdominal area seemed unaffected. I looked into this further and came across an old manual on the production of live food for aquaculture, which was produced by the Food and Agricultural Organization of the United Nations. In here they talk at length about brine shrimp, and even mentions this condition, calling it black disease or black spot disease, where black spots appear primarily on the extremities, such as on the thoracopods and antennae. This disease consists of the detachment of the epidermis from the cuticula, and is caused by a dietary deficiency which interferes with lipid metabolism. In high-density cultures of Artemia using agricultural byproducts as a food source, the black disease is observed where water quality deteriorates, probably interfering with the composition of the bacterial population and consequently the diet composition, and/or when feeding rates are not optimal. So this definitely seems to be what we're observing, but rather than poor water quality deteriorating and causing the issue, these aquadragons have probably developed their black spot disease because of the microplastics interfering with their ability to absorb nutrients. Now we'll move on to our final tank, the boomers. This aquarium is yet to receive any microplastics, but today they're going to get a mega dose, everything we have left. This is how algae research supply intended for the experiment to be run, with mature adults being fed a large amount of the fluorescent microplastics and then the results being observed. Now before I feed these guys the fluorescent powder, I'm going to carefully move the adults from their large tank into the originally supplied culture flask, which was quite a bit smaller. This is basically to increase the density of microplastics in the water and hopefully make any potential effects more pronounced. Now since I've only been feeding this food to one tank in really small quantities, I still have a surprising amount of it left. So even though it's slightly less than what algae research supply intended here, the effect should be comparable. And since the acrylic is so intent on floating, I'll give it a quick swirl to mix everything up and make it easier for our aquadragons to eat. So the first thing I noticed here, which is really cool, is that the powder is letting us clearly see the location of the brine shrimp's mouth, which is usually quite difficult to see. The mouth sits on the ventral part of their head, which for brine shrimp is on their back, because they kind of swim upside down. You can see that yellow colour accumulating around the mouth as it enters their body. Because there's so much of the acrylic powder in the water, it only takes a few minutes for their gut to begin filling up, so it's time to check them out under the black light. We'll look at them in the tiny plastic dishes that algae research supply gave us, as it should make observation a bit easier. This is honestly incredible to see. I knew the effect would be quite obvious, but I wasn't expecting them to glow quite this brightly. The fluorescent food is collecting towards the end of their digestive tract, and they're even starting to poop it out. This is what we observed with our Gen X tank a few weeks back, but with a much stronger effect now. I also noticed that the egg sacs on the females glow a bright blue colour. I'm not really sure why, but I thought it was worth noting. So, why should we care about brine shrimp consuming microplastics? Can this experiment tell us anything about how we might be affected? Well, microplastics have now made their way into almost every ecosystem on Earth, and when they're accidentally ingested by small animals like these aquadragons, they leave their environment and then enter the food chain. Larger animals, such as avian predators, then eat these Artemia, transferring those microplastics up the chain, where over time they bioaccumulate, concentrating the microplastics within an organism's tissues. They're not always easily broken down or excreted either, so if they're in the foods we eat, they'll often persist in our bodies, where they can cause inflammation, endocrine disruption, or like we've seen with these brine shrimp, cellular damage. While avoiding microplastics entirely in the modern world isn't really possible, there are things you can do to limit your exposure. Reduce your use of plastic packaged food and bottled water where possible, opting for glass and stainless steel instead. Airborne microplastics are known to be particularly problematic too, so using in-home air filters and good ventilation while cooking can go a long way. When it comes to clothing, try to opt for natural fibres rather than synthetic textiles. And lastly, if you're going to keep aquadragons or sea monkeys as pets, I'd recommend just sticking to their regular food. And since this experiment is now finished, I'm going to move these guys into a single large tank where they'll live out the rest of their days with clean water, a lot more space to swim around, and a natural diet of live green microalgae. Thanks for watching, and I'll catch you in the next one.